Hello everybody, this is Dr. Benalia from University Boumerdès, Algeria. In this video tutorial, we are going to learn how to solve and implement linear programming of hydrocarbons transport problem. Now let's represent the hydrocarbons transport plane of company Sonatrach. In this plane we have production points as gas and oil stations, with distribution stations and with processing stations. The points are connected by pipelines. Now we can represent this plane by transport network. In the inputs points we have production stations, and in the outputs we have processing stations. In the intermediate points we have distribution stations. The points are connected by the pipelines. In our case, we focus on linear programming of hydrocarbons transport problem. This problem is defined by production points, for example, drilling wells that denoted by P1, P2, and so on until Pn with production capacities. On our side, we have processing points, for example, refinery station, that denoted by R1, R2, and so on until Rm with processing request. Between production and processing we have the pipeline. Now we can denote by Xig the transport quantities from production into processing, and Cig the transport cost. The objective is to determine the optimal quantities Xig in order to optimize a certain objective, for example, minimize transport cost or maximize the energy. In our case, we focus on minimize the transport cost, that modeled by double sum of Cig times of Xig. Subject to constraints, we have capacity constraints, which means transported quantities from production must be lower than production capacities, and we have request constraints, which means the transported quantities from production is greater than processing request. Now let's give the example. We have two production points, P1, P2, and three refineries, R1, R2, R3, with Cig and with refinery request and with production capacities. The objective is defined by expression I and subject to capacity constraints and request constraints. For example, for production P1, we have x11 plus x12 plus x13 is less than 900 is equal capacity of P1, and for request constraints, for example, x11 plus x21 is greater than 450. Now for MATLAB programming, before we need the MATLAB mathematical forms, as for objective function defined by expression 1, for where f is cost vector and capital X is decision variables, and inequalities equations defined by expression 2, and we need equalities equations defined by expression 3, and we have bounds condition with less bound and with upper bounds. We can apply this form in our example. We get this expression but we need transform greater inequalities into lower inequalities. We just negative this. For example, these equations x11 plus x21 is greater than 450 is going to minus x11 minus x21 is less or equal minus 450. Then we get the matrix form. In summary, we have the matrix form that we can apply the MATLAB program. The objective is to determine the optimal variables x, I, g. The program is following by data initialization and command. Now start for MATLAB. We put the program in MATLAB. We have the optimal solution. x11 is 450, x12 and x13 and x21, x22, x23, and value of final value. Thank you guys for watching. If you enjoyed this video,